So today we will learn very important topic regarding how are the circuits in our house, whether it is in series, parallel, and why we have adopted this system. Let us learn about the electric wiring in our house. We will start from power station. Like we have got thermal power stations, nuclear power station, hydro power station. All these power stations produces electricity and they feed at around 110 kV to 132 kV to our grid. That grid will bring the electricity to our city. In our city, again there are step down transformers so that the voltage will get reduced, and finally there will be a step down transformer near our lane where it will get converted to 220 volt AC. So that 220 volt AC will come in our residence. In our residence, I will show you with that diagram. Residence means each building is having some meter room. So it will come to the meter room. So you can see L and N. I have marked here L and N. L means live. It is having potential. Neutral means you can assume it is zero. So this is our neutral wire. This is our live wire which is having potential. So between L and N there is a potential difference of 220 volt. So this power supply we are getting from our power company. Now in the live wire the company has installed main fuse. So this is the main fuse of the company. After the main fuse they have installed electric meter which also belongs to them. So whatever power supply they are going to give to us would be measured by this electric meter. Okay, from electric meter live and neutral wire will come out. This is live wire, this is neutral wire. So this is the main switch. Like in case we want to work in our system, wiring system, then we can switch off and then work without any problem. Okay, now here you can see green color. This is the earthing wire which we have connected from a meter, and this wire is going to earth. This is buried inside the earth. This is a copper plate. So this is the earthing we have provided to the meter as well as to the main switch, and then this earthing wire will also go to our house. So this is the earthing wire, this is the live wire, this is the neutral wire. So these three wires I have shown. This I have just shown as a concrete wall, and now they will enter our house. So live wire is of red color, neutral wire beam stands for black, earthing wire is green color. So these three wires now will enter our house. This is in the meter room. So in case you want to do any work in the electric wiring in the house, you should switch off this main. Then it will be totally safe. I will explain to you about this earthing. Now you can just remember that this is the earthing connection we have provided, and this earthing wire is also coming to our house. So this is the how we get our electric supply in our residence. So in our residence these three wires will come to the main junction box, which I will show you in the next diagram. So you can see this is the main junction box. This junction box now is getting three wires. Earthing, live wire means red, neutral means black. So these three wires we are getting in our main switch junction box. Then here now we will make various parallel connections, and one set of parallel connection will go to each room. So that each room parallel connection will have miniature circuit breaker, so that in case there is any problem in the wire, in the wiring or in the appliance, the current becomes more, then the circuit breaker will trip of only that particular room, and then we can rectify and switch on the MCB. So this is in each flat we are having this main switch which is also having MCBs. So now I will just show typically one room. So this is a green wire, earthing wire. This is red means this is a live wire. Black means it is neutral wire. So these three wire I have taken to one room. So first point to be noted is that in the distribution box we are having these three sets for each room or for each circuit. And so now each circuit will behave independently, will get 220 volt, as we have learned that in parallel supply, isn't it? We have learned that whenever things are in parallel, now this is our main power supply. I have just shown two circuits. You can have more also. Any number of circuits you can have. So this is 220 volt. So if this is 220 volt, each room will get 220 volt. So that now each room is getting full 220 volt supply. Now in each room also we will have various appliances. You may have a geyser, you may have a refrigerator, you may have an AC and some lighting, some sockets would be there. Sockets mean, I have shown it here, that you might be having such sockets. This is live, this is neutral, this is earthing. So the wiring are coming behind the wall, and earthing wire gets connected to this socket, live wire gets connected to this pin, and neutral wire gets connected to this pin. So when I put my plug, I will draw live. From live I will draw positive, from this is neutral, so that current will return back, and earthing I will explain what is earthing. So earthing wire will get connected here. Okay, so now we will see further. So now I have got the three wires, live, neutral and earthing. Now these three wires, nowadays we run this wire along all the four walls of the room, so that wherever I want electric supply in future, I can easily draw by making connection from the wall. So this red, live, black, neutral, green, earthing are running all along the four rooms of the room. Now I have shown typically four connections. So you see, this is an appliance. Suppose this is a refrigerator. So the body of the refrigerator is connected to this earthing, so that in case of a fault, if body gets some power supply or potential, it will go to earth, and from here, this has come from the buried plate in the earth, so where the potential is zero, so that person touching the appliance will not get a shock. So earthing is a safety wire, so that person should not get electric shock. Now this is a live wire. In the live wire I have shown a box. It is having a fuse and a switch. So I have got a fuse and switch for this appliance, and live wire is coming here. So I am getting a potential, and the current has to, we have to make the circuit complete. So this is a neutral wire. Neutral wire is going back to the meter room. Okay, so this is the complete path, that live wire comes to the appliance and it goes by a neutral wire, like you have got power supply which you have done, isn't it? I will draw it here, like suppose this is a power supply. This is the power supply, and now from power supply I am making a conductor and it is returning back, so it has to come back. So in the same manner, R is this wire and this return wire is neutral wire. So this goes back to the meter room. So it will go back to the power supply company. So this completes the circuit. Earthing I have explained to you. So now all appliances are connected in the same manner in parallel. So in this manner our wiring takes place in the system. Now I will explain to you why we have this system. Let us read now that. See, so this system is called ring system. This system is called ring because we are having the wiring all along the four. So this is called a ring system. So nowadays this is commonly used system in cities. Okay. So in the ring system, live, neutral and earthing wire are for each room. I have explained so all those things. I have explained so distribution box has fuse and MCB for each ring. And in each room, all appliances are connected in parallel with individual switch. See, I will come to that, the uses of this. Now appliance body is connected to earthing socket, and from the socket the earthing wire will go to the earth, so that person will be saved from electric shock. Now you see, suppose this is the appliance. Due to certain defect in the appliance, the live wire is touching the body of this. This is the live wire. It is touching the body. So now if a person touches this body, he will get a shock. But if I take this body and connect to earth, this is the symbol for earthing. So then this becomes a least resistance part. So current will flow to the earth and a person touching this body will not get a shock. So having earthing in all our appliances is very, very important. Now, what are the advantages of this ring system of wiring? See, if you would have seen in this diagram, now this is an appliance. This appliance is getting power from two ends. One is this end as well as from this end. From two ends it is getting. If we consider this appliance, it is getting power supply from this end as well as from this end. So I can use thinner wires. So that's safe. And second advantage is, in future if I require a connection, I know wire is running all around the four box. So where I want to keep my appliance, I will have to only take a connection from the wall. Then each appliance is having separate fuse and separate switch, so that if any fault will develop, that appliance fuse will blow off, or at the most that room fuse will blow off in a junction box, and I can, all the rooms will not get affected, and I know the fault is in this room, so I will check and repair, and then we have to reset the MCB circuit breaker. So these are the advantages. First, thinner wire is adequate because we are getting potential from two ends. Second, any connection is required in future, it is easier. Third, I can individually switch off my appliance as it is having a separate switch and a separate fuse. Then, why we are using parallel connections? Parallel connections advantages are, each appliance gets full 220 volt, so that my voltage does not get distributed in parallel. All appliances will get 220 volt. So all my appliances which are sold in the market in India are rated for 220 volt. So there is no confusion that of what rating I should purchase an appliance. Second, each appliance operates independently. In series, as you know, the same current flows through all the appliances. So I can have, if I switch off, then all the appliances connected in that series circuit will get affected. So this is the most important reason that my all appliances are running independently. So in case of any malfunction, I can switch off. If some appliance is making noise, you can switch off that and then check it. Or full wiring or the various other equipment, appliances connected in that room will not get affected. Okay, so these are the main advantages. Now you see, fuse and switches should always be connected in live wire. I will explain. Suppose this is some circuit, some switch. Now this is the live wire going, this is the live wire is going, and then it is coming out here. This is neutral, this is live, this is neutral. Now in case I keep a switch here, if I keep a switch in this neutral wire, then even if my switch is off, my potential is coming to this body. My potential is coming to this in the live wire. So if a person is doing some repairing, he happens to touch this live wire, he will get a shock. But if the switch is in this live wire, here is the switch, then when it switches off, then there is no power supply. All live wire will have no power supply. Therefore, switch should always be connected on live wire and fuse should be on live wire, so that my appliance will not get any potential, so person can safely work. Is it okay? Now series connections are having various disadvantages. First, as I told you, in parallel I can switch on and off each appliance independently. So in series that is not possible, so this is the disadvantage. Second, voltage will get divided, so all appliances will not get 220 volt. Third, in series circuit, current is same in the full circuit, so even my appliances which require less current, like the mobile charger, will get very high current, and the room heater which requires more current may get less current. Okay, and in series circuit, effective resistance is high, it is addition of all. In parallel, it is less. Is it all right? So these are the main disadvantages. So we always connect our appliances in parallel. Like you might have seen that during festivals we keep small 100 bulbs or 200 bulbs in our garden or outside our house. Now, if they are all in series, so if one bulb fuses, one bulb has got disconnected, no bulb will light. Electrician will find it difficult to locate that where is the fault. But in case of parallel, only the circuit in which there is a fault, that bulb will not glow, but others will glow. Okay? So this finishes our domestic circuit. Okay, thank you. In case you have liked my explanation, you can subscribe to the channel if not done. Otherwise, like the channel and press the bell icon so that you will come to know when I post the next video. Thank you.